Hello everyone, welcome to AI Anytime channel. So in today's video, we are going to have a look at something called Segment Anything model, which has been released by Meta AI. They have released an image segmentation model, and we are going to have a look at that model that they have released, what kind of features that provide, what are the model checkpoints available for uses, what are the licenses, and how we can use it for different use cases. This is what we are going to do in this video, guys. So if you see, I'm currently on Meta AI website, which says introducing Segment Anything under their computer vision tag. The computer vision, it's kind of a blog. It says working toward the first foundation model for image segmentation. So this is the blog page that they have. It contains different use cases for this model. The model is basically has been called as SAM, Segment Anything model. So if see, this is a more detailed page which is on segmentanything.com. They have their dataset blog and also the paper that I will discuss as well. Here is the paper, and they also have a GitHub repository containing all the model checkpoints and sample notebooks and also the datasets which has been trained on. Okay, and you see it says Segment Anything model, a new AI model from Meta AI that can cut out any object in any image with a single click. And it's amazing because it says a promptable segmentation system, okay, with zero sort generalization to unfamiliar objects and images. So the most important thing with this model, the SAM model, is that you do not have to do additional training or perform additional training on the objects that you have, right? So you can just use it to cut those objects out. And the most important use case, I believe, okay, where I think that will be in AR and VR industry, mainly in the augmented reality world. You will see a lot of applications that requires this kind of image segmentation model, where you have to kind of highlight some objects in that AR world. This model will be extremely helpful for those use cases. If you come down, you see it has this prompt features as well. They have a lot of videos, samples, demo sample that they have. They also have zero sort generalization, which is very important. If you read, it says a general notion of what objects are. This understanding enables zero sort generalization to unfamiliar objects. Now, most of the time you have unfamiliar objects and you are working with other segmentation model. For example, if you are using unit architecture to segment something, first you have to annotate those data, you have to label those data, and requires a lot of efforts to do that. So it provides zero sort generalization to unfamiliar objects and images without requiring additional training, and this is very interesting. You see, they also have a demo. It says go to demo. Now if you click on that, it will take you to this demo. You have to first accept that. Okay, sorry. Click on that. You can see you just click on hovering or Sam is running the. So they also have a demo where you can interact with that, but I'm not interested in that part right now. See, this is a paper that they have. They call it Segment Anything, which has been released by Facebook AI research. It's nowadays called as Meta AI research as well. So now if you see, if you come down, they have everything about the data engine, the data that they have trained on. It says, if you read this, it says our final data set includes more than 1 billion masks. They also have released that data set for uses. You can also have a look at that. They're also talking about responsible AI and those sort of ethical component as well. And you can see some of the images, the mask images from that data set. Segment Anything task. Little verbose as well. If you come down, you will see they're talking about all the how this is different from other segmentation model that we have, okay, previously. If you come down, they have all this evaluation metric and the way they have trained it, and all those metrics are here. We'll also talk about intersection over union as well, which they have also discussed that in the notebook. So we'll also try this SAM model in Google Colab in bit. If you come down, this is the paper. You can also have a look at this paper. They also have a kind of a web interactivity where you can try with your images, and as well you can upload, and you can also select from gallery as well. So this is also available. and this is the blog site that they have. Okay, they were talking about gauge based object detection, and I do believe that this is going to be very powerful in augmented reality world. Okay, you can see that they're also showing it here. In the future, SAM could be used to identify everyday items via AR glasses. Now we have AR glasses coming in. Okay, so you can directly have this model integrated with these AR glasses. Now here is the most interesting thing. Okay, and I'm also interested in this one. They also have a GitHub repository with all the this very neat and clean documentation. They have a readme how to install this locally. Just for your information, if you want to run this model, of course it supports ONNX, ONNX. You can also run it if you have ONNX environment, but it does require a GPU machine. You need a GPU machine to run this model locally. Okay, so and that to a powerful one. Okay, so I'm using have an NVIDIA GPU, decent GPU having 4 GB RAM as well, but it can also does out of memory as well. So you require a powerful GPU to run this model offline if you want to run it. So they have these models here. You can see it says model checkpoints. This is the model available. You can download it, and how to run this model. They also have given this option here in getting started. So first download a model checkpoint, and then you clone this repository, keep the model in that directory or anywhere else as well, and then you import it. We'll see that the files, the classes that they are using, SAM predictor, and you pass the model. This code do have some typos, okay, that they have been fixed now. Earlier it was there have been some typo earlier. You can find that more in the issue. If you come in the issues, you can find different issues that have been now I think have been fixed. So let's do one thing. Let's go back to Google Colab, and what I will do, I will upload the Colab notebook. This is a sample notebook file that I have. I'm just uploading it, and I will use that to see how better it's generalized when you compare other segmentation model. We'll see the SAM model in in a real demo now, okay, on a sample image. So if you talk about the most important application of image segmentation model, I think most of the time you see people are using these models in healthcare, basically for medical imaging. When you have this medical images like CT scans, MRI, and different other formats, and these kind of model have been used to find out the anomalies, find out the masked in those medical imaging images as well. So this is what we are going to do. We'll take a sample image that's going to be maybe a CT scan image of lungs, or maybe an MRI scan of a brain, okay, the occipital lobe, and then we'll try to use this model and see if it's being generalized well on those images. This is what we are going to test. Okay, so if you come over here, you'll say automatically generating object mask with SAM, which is an acronym for segment anything model. And let me just and you require GPU for you. That's why I'm using Google Colab, because it works well for at least this inference. And if you want to fine tune it, you can also fine tune it. For that you need a high computational power of GPU to perform that task. So if you come over here, you'll see that, let me first mount this. Just mount this to my drive. Just in case if I have to save the the model weights, I can do that, but I will not do that in this case. But anyway, it's good to mount it, so I'm just mounting with my drive. Anyway, let's upload couple of sample images. Maybe I can upload, I don't know, if I upload this CT lung with JPG image. I'm just uploading this image, and I hope the runtime is GPU. Let me just have a look. Okay, runtime is not GPU, so again I have to make those changes. So I'm changing the runtime to GPU because this segment anything model requires GPU to run this notebook, and also to make this inference. So once it is done, if you come over here, some of the dependencies that you see, it's OpenCV Python. We have Cocoa tools, that may be for the Cocoa dataset that we have for the classes and all. We have Cocoa tools, then we have Onyx runtime, Onyx, and Matplotlib. These are the dependencies. These are required to to inference this the notebook. You need this dependencies to run this segment anything model. So this is done. Now let's do one thing. Let's upload that image. See, I'm just uploading this citylung.jpg image, and now what I will do, I'll just start running the notebook. What it says, this is the class SAM automatic mask generator. Because this notebook or the model, basically the SAM model has a class called SAM automatic mask generator. Implements this capability. It works by sampling single point input prompts in a grid over the image, from each of which SAM can predict multiple masks. Then masks are filtered for quality and deduplicated using non-maximal suppression. Additional option allows for further improvement of mask quality, that we'll see. It provides additional options as well to improve the mask quality. They're also given that in this notebook as well. So I have this sample image, and now what I will do, this is okay, we do not need this, but anyway, I'm not going to make any changes. I'll just do this false to true because I'm going to use Colab. If you're running it locally, you have to keep it false, because if you're running it locally, you would have cloned this repository, segment anything model repository. In that case, you do not have to perform this activity here. You can also download the models from this model checkpoints. You see this model checkpoints over here. If you come down, model checkpoints, you can download all the models from here. But here we're directly downloading it, and we'll keep it in the runtime here. You see in the left hand side, this once you run this, and once I ran this, I can see it will be downloaded the model checkpoint. One of the model checkpoints, we are using this one, SAM VITH, this one. It also has other model checkpoints as well. This is available here. You can also try with that as well. These are, I think, the differences are in, of course, in the trainable parameters and of course indirectly the size. And I think this is the largest one. There are a couple of other models checkpoints available which are which doesn't require a high computational power when you compare to this one. Now let's do a refresh. Now you can see that I have this model checkpoints in this runtime. You can also store this in your drive if you mount it. I have mounted it, but I'm just using it for inference purpose. I will test this image city_lung.jpg, and they also have a sample images, which is I think a dog image. You can see it over here. Now this is done. Now what I will do, I'll just import some of the dependencies which are already being installed by default in Google Colab. You do not have to install these dependencies, but if you are running it locally, you need PyTorch with CUDA support. Then you have OpenCV and NumPy and other utilities as well. Now just I'll run this. These are basically function for the mask that we have, the polygons that mask. Now this is the example image. I'm not going to use this image, so what I will do, I will use this city_lung. I will just change the image direct path. This is the image. This is the one that I'm going to use. I'll just run this, and I'll just use Matplotlib to show that image. So this is basically a CT scan image of lung, where you can see a tumor right there, okay, in the right hand side. I would like to use the SAM model on top of this image. I would like to see how good it generalized on this one. Okay, this is what I'm going to see. So it says automatic mask generation. This is the SAM checkpoint. If you have any other checkpoint, you have to probably rename this according to the checkpoint that you have. And I have CUDA, of course. I am using the GPU support of Google Colab. So I will just run this. It also says here, to run automatic mask generation, provide a SAM model to the class and set the path below to the SAM. That we already have done it. And now you see here what it does. It says from segment anything, import SAM model registry, this class and SAM predictor. If you come over here, you will see in this module that we have segment anything. If you go, you see this automatic mask generator.py. They have build SAM and predictor. So if you see, we are using this SAM automatic mask generator, SAM predictor, and SAM model registry. So if you come over here, you will see all the code base over here. This is the class that we are going to use, guys. This is class SAM automatic mask generator. It has all these parameters. If you come down, you will see all the layers and everything over here, the way it has been trained on, the results and everything. I'll show what I'm talking about. So now once you run this, what it will do, it will import all these classes which are required, and then what it does, it binds the model. We are using this checkpoint, this SAM checkpoint, and then we are using on the GPU machine, so we are doing this piping it to CUDA. Okay, so it pipe with the CUDA SAM .2 device equal device, and then we are having this mask generator variable where we are passing this SAM variable which loads this model checkpoint. Now what we will do, we'll generate the mask on this image, the image variable that we have on top, this image. So now let's do one thing, let's run this, and now if you see, it says mask generation returns a list over mask, where each mask is a dictionary. It will give you a dictionary containing various data about the mask. And if you are aware about this segmentation area, if you are aware about IOU, which is intersection over union, it's better. Otherwise I would like to explain it in a short. Let's just print this. It says, it gives us this dictionary having segmentation area. It was also mentioned over here. We have the length of the mask, which is 33. Now let's plot the mask that we have. So I'm plotting the mask that we have generated, and without any training, guys. I haven't done any training. If you are looking for some kind of tumor segmentation and stuff, you can also fine tune if you have data. Of course, you can fine tune for your task. It should work. And I will fine tune on some kind of data sets to see how good it generates. You can see this is the mask that we have we have received. Okay, so let me just save it on desktop. I like to see it, and this looks nice, by the way. This looks great. Okay, so this is the masked image that we have got the segmentation using a SAM model, segment anything model. Now let's do one thing, let's go back. It also says automatic mask generation options. Now let me just do one thing. What I will do here, guys, after this, let's print masks and see what we are getting. So I'm just doing masks, and you can see we are getting the some of the values over here. Okay, if you're getting this different bounding boxes, values, coordinates, area, predicted IOU, point coordinates, stability score for each of the segmented mask that we have, right? You can see the total length is 33. Now what do you mean by IOU, guys? Which is very important for segmentation model. So this is not the first time that we are working with a segmentation model. So let's talk about IOU, guys. So if you are aware about what IOU is, which is nothing but intersection over union, which is very fundamental to understand. If you have earlier worked with any segmentation model, if you have worked with any unit for biomedical imaging segmentation or any other task, if you have worked with mask RCNN, or there have been different algorithms and model that people have used for segmentation. So IOU is very fundamental. Now just understand high level view. Okay, now if this is, let me just draw something. So I'm just drawing. Okay, and now what I will do, now this is the overlap. Okay, so basically IOA is like area of overlap between the predicted segmentation and the ground truth, divided by the area of union between the predicted segmentation and the ground truth. So let me just explain what I mean by that. Now suppose, for example, if this is your X and this is the Y area and this is the overlap. Okay, so this is how we donate this one. Okay, this is how we donate this. And now suppose, for example, the same thing, now if this is my complete overlap in this, just see the area of overlap here. Now suppose one is the predicted one and one is the ground truth. and now this defined as X union Y. So the formula of IOU becomes the intersection, I'm just writing intersection of X and union of XY. So this is the formula of IOU, okay, intersection over union. This is very important for as a metric when you work with an image segmentation model, and this is what you'll also see it over here when you are getting this, when you are printing this mask. For every that we have the length, if you printed the length of that mask, for every mask that you see, you are getting some kind of predicted IOU, which works like an evaluation metric, which is very important to evaluate your segmentation model. And then you have the bounding boxes, and then you have the stability score as well. So you can also read it over internet. There are a lot of documentation and cheat sheet available for IOU as well. Now if you come down, it also provides fine tuning. You can see the tunable parameters. Now if you are not happy with the generalization, that the generalization is not good on the image that you have tried with SAM model to perform, if the output is not coming good, you can also tune the parameters. You can do hyperparameter tuning here. So it says there are several tunable parameters in automatic mask generation that control how densely points are sampled. Now you can also have a look. It's very interesting. Now let me first run this. Densely points are sampled, and what the thresholds are for removing low quality or duplicate mask. Okay, so it can remove the low quality and duplicate mask. Suppose for that duplicate mask in your output image and you want to remove that, you can tweak this as well. If you see the tweak one, it says the same model, points per site 32. It also have a threshold. Okay, this is the threshold value that I have, which is 0.86, the IOU that I shown you, right? The intersection divided by union of X and Y. Okay, and then we have stability score threshold. So we have set some threshold, we have some crop values, and then we have some downscale factor. You can see crop and points downscale factor as 2. Now we are tweaking it. Let's see the result for this one. So we are calling it mask 2. I'm just using mask generator 2.generate. We are passing this method on the same image. It will take little time. It's running on GPU. Even on GPU for a single image, it takes around 20 to 30 seconds. For the first one, if you see the length of the mask that we got around, I think it was 33. You can see it was 33. Now let's see for this one. It is 48. Now what we will do, we'll just show that output image, the segmented image. So if you can just show the first image, then let me just bring the first image as well. Here is the first output that we, this is the first output. Now this is very good, by the way. Okay, if you see that this has been segmented tumor. Okay, now this has been successful, and let me just also save this. And now you can see, so this is the first image that we got, the first output when without any tuning. And if you see the top one after tuning, you can see it's I think it's okay. Now depends on the different type of task that you are performing. Okay, that depends, this tuning depends on that. You can also fine tune it on your data and see how it's working. But this is very simple and powerful to to run and make inference at least on the sample images or the sample some of the tasks or use cases that you have. Okay, and I think they also have a web UI. Okay, you can also use this tool. You can have upload some of the images. If I click on, I don't know, if I click on this download, let's click on this brain MRI tumor, extracting and embedding for the image. Okay, so it also provides a web UI. Similarly, you have worked on a notebook. This is more programmatical. You can use this program it for different set of use cases. This is just for quick testing. Now let's do one thing. I'm also interested to change this image. Now if I upload this image to the brain image, and if you just try it once, I'm just going to call it brain MRI tumor .jpg. I'll just run this. I do not have to run this. This has been already run. I'll just run this again. So masks equal mask generator dot generate image. I've changed the image. This is already working on. You can see cut out the selected object or try multi-task model. This is very good. If you see, it has a lot of features as well. If you see cut out object box, they have hover and click, which you can click on here. But anyway, you can play with this. So what I will do, I'll just come back here on this mask. I'll just print. Makes sense 15, because if you see that image, it doesn't contain much. So if you come down here and just, I'll not run this mask. I'll just plot this. So let me just plot this. So I will share that link in the description, guys. All these available artifacts that you see, like the blogs, that research paper, that the web UI, the demo that you can use, and also the GitHub repository, which is very important if you want to fine tune it or try it to make some inference. Now let me just save it as well. See, this is what we have got, guys, for this one, and you can see it over here. Your tumor is right there, at least according to the image. Okay, and it works out of the box. You can also cut it out. You can also use it for I don't know, maybe classification as well, but that we have to see. So it works fine so far. It works, I'll say, superb. It's working great. You can also try it out. I just wanted to play around it and see what kind of response we are getting. Okay, the output, and it generalized very well. Okay, as they mentioned about zero sort generalization, without additional training, it works well. So I think Facebook AI research is also working nowadays. With a lot of large language models coming up. They have a lot of things in their list that will be launched, and this is a very welcoming one. They also had released earlier the NLLB, no language left behind. So I think the research unit has been working fantastically for at least open source community, and these are all welcoming steps. So if you like the video, okay, please hit the like button, and if you haven't subscribed the channel yet, please do subscribe. Okay, I'll create more content with futuristic AI things. And if you scale this, or if you extend this further, okay, what are the other things that you are doing with this? If you have any thought and feedback, please let me know in the comment. You can also reach out to me. So that's all for today's videos, guys. Okay, thank you so much for watching. See you in the next video.